Hello, good afternoon to all of you. Today we are going to start the chemistry second unit number third of the organic chemistry. In that we are going to study the stereochemistry. So in the stereochemistry we have the view to see the molecules. In general view we are writing on the tables in the 2D views, but actually stereochemistry give us the 3D and 4D views. 3D views, how molecules looks like. So that's why stereochemistry is most important, because in organic chemical molecules, stereochemistry decide the product, affect the product. Stereoisomers are having the same molecular formulas, but only different in the orientation in the space, or only difference in their structural formulae. So that's why it is important to us to study this stereochemistry, because in the chemical molecules, if the isomers, one is the R and second is the S, both having the different chemical properties, looking same, but only difference in their arrangement in the space, arrangement in the isomers, different form of isomers, only mirror images, diastereomers, RS configuration different. That's why its chemical properties also changes. That's why stereochemistry is most important. So stereochemistry is a Fisher projection formula, Newman projection formula, Swaha's projection formula, and their interconversions are involved in this syllabus. Geometry, isomerisms of alkenes, cycloalkenes, cis and trans, and the C90 isomerism, EZ notations with the CIP rules is also included in our syllabus. Then the optical isomerisms, optical activity, specific rotations, chirality, or symmetric enantiomers molecules with two similar and dissimilar chiral centers, diastereoisomers, mesh structures, racemic mixtures, resolutions, relative and absolute configuration, D1, RS designations, conformations, analysis of the alkenes, ethene, propenes, relative stability with energy diagrams. This all we have to be studies in this chapters. Now, flying wedges formulas. This is the common representations of the formulas here by using the flying wedges formula. The representation board projections above the planes and the below the planes, here the molecules. The solid wedges are looking on the above the planes, represent the plane, the projections above the plane of the papers, and the broken or detached wedges are pointing the away from the observer, and the continuous lines indicate the bond in the plane of the papers. So this is give the 3D view to understand all these things, how to be molecules looks like, how to be solid wedges and simple wedges are looking nice. For the study of this we have the one PDF how questions will be asked. 1 minute. We have the PDF is also the indicating the wedges, the compounds whose molecules are shown in the below would have. Here the molecules are given here. In that options A, same melting point, different melting points, equal melting points, more than one melting points, none of the above. These are the different questions asked on this by using this confirmation formulas. Here is also important of this wages formula in the asking the enantiomers of the following substances. So even given here ask for the 2, second, third and fourth. So it is most important to study this wages formula above the plane and the below the planes. Okay. So in the next lectures we will discuss the how question will be asked on this wages formula and what are these different concepts related with these formulas for understanding the molecules and understanding the structure of the molecules. Okay, how the isomers are there, which are the isomers, which are the enantiomers, all these things. So in the which of the question one, which of the following is the enantiomer of the following substance? One compound is given here is the question number one. In that, so Br is the solid wedges above the plane, hydrogen below the planes, and CS3 and hydrogens are in the planes. So its opposite is the same opposite is the above the plane will be look in the below the planes and below the planes look in the above the planes. So answer will be the answer will be the that it does not have any enantiomer or non-superimposable mirror images, because in this case how do we understand that if you are fixing the constant that is CS3H that is in the planes, then the above the plane and below the plane will be changed. So here is the fix not fixed hydrogen CS3 in the planes, so it changes, and along with the Br and hydrogen also changes. That's why option D is the correct answers. Thank you.